everyone and to all of my happy friends, especially to my grade 9 students. Our lesson for today is all about trigonometric ratios. But we will be focusing first on sine, cosine, and tangent. Let's get it on.
Before we proceed to the computation, it's very important to know the parts of right triangle. A right triangle has the opposite side, adjacent side, and hypotenuse. Hypotenuse is the longest side of a right triangle, so this is the hypotenuse. Considering this reference angle, this is the opposite side. And this is the adjacent side. Considering the theta, which is the reference angle, this side is the opposite side. And this side is the adjacent side. If the theta is placed here, this side will be the opposite side, and this side will be the adjacent side. The hypotenuse will still be the longest side in a right triangle. Let us proceed with the first three trigonometric ratios, starting with sine. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent, which is equal to opposite over adjacent. In order to memorize it easily, all you have to do is to have this SOHCAHTOA. SOHCAHTOA. So stands for sine is equal to opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Okay, are you now ready for our examples? Example number 1. The given sides are 5 and 12. Since we are looking for the hypotenuse, we are going to use the Pythagorean theorem. Applying the formula of Pythagoras, we have here C is equal to A squared plus B squared. So we have C is equal to 5 squared plus 12 squared. 5 squared is equal to 25 and 12 squared is equal to 144. Then we are going to add 25 and 144, which is equal to 169. And square root of 169 is equal to 13. Therefore, the value of the hypotenuse is equal to 13. Let us solve for the trigonometric ratios, starting with sine. So having this one we have here opposite over hypotenuse to get the sine theta. So considering the triangle, the opposite side is equal to 5 and the hypotenuse is equal to 13. Therefore, sine theta is equal to 5 over 13. Second is we have the cosine, which is ka. Cosine theta is equal to adjacent over hypotenuse. Considering the given, the adjacent side is equal to 12 and the hypotenuse is equal to 13. Therefore, cosine theta is equal to 12 over 13. And the last one is the tangent theta. So we have here TOA, so the formula is opposite over adjacent. Considering the given, we have here the opposite side, which is 5, and the adjacent side, which is 12. Therefore, tangent theta is equal to 5 over 12. Okay, important reminders for fraction. Reduce your answer to lowest term if and only if it is necessary. Example number 2. We have the given hypotenuse, which is equal to 8, and the other side, or the opposite side, is equal to 4. And since we are looking for the adjacent side, we have this formula, A is equal to the square root of C squared minus B squared. So we have the square root of 8 squared minus 4 squared. 8 squared is equal to 64 and 4 squared is equal to 16. 64 minus 16 is equal to 48. Since 48 is not a perfect square, we are going to manipulate it. Square root of 48 is equal to the square root of 16 times 3. And the square root of 16 is 4 Therefore, the adjacent side is 4 square root of 3. Again, let's solve for sine theta. So we have here saw, which is equal to opposite over hypotenuse. Considering the given, the opposite side is 4 and the hypotenuse is 8. So we have here sine theta is equal to 4 over 8. And since 4 over 8 is divisible by 4 over 4, our answer is sine theta is equal to 1/2. Next is cosine. Cosine theta is equal to cos, so we have adjacent over hypotenuse. Considering the example, we have here the adjacent side, which is 4 square root of 3, and the hypotenuse, which is equal to 8. Therefore, cosine theta is equal to 4 square root of 3 over 8. Since 4 and 8 are divisible by each other, we can cancel them. 4 will become 1 and 8 will become 2. Therefore, our final answer is we have cosine theta is equal to square root of 3 over 2. Then, let's solve for the tangent theta. So, we have here TOA, which is equal to opposite over adjacent. So, considering this one, the opposite side is 4 and the adjacent side is 4 square root of 3. Tangent theta is equal to 4 over 4 square root of 3. And we can cancel 4 in the numerator and 4 in the denominator. So we will be having 1 over square root of 3. If the denominator still has the square root symbol, this is not yet the final answer. We are going to rationalize the given by multiplying the fraction by the denominator, which is square root of 3 over square root of 3. 1 times square root of 3 is equal to square root of 3. Square root of 3 times square root of 3 is square root of 9, and the square root of 9 is equal to 3. Therefore, our tangent theta is equal to square root of 3 over 3. Okay, another important reminder. If the denominator has the square root symbol, that is not yet the final answer. We are going to use the process of rationalizing. And rationalizing is actually the process of removing the square root symbol in the denominator by multiplying the given fraction or the given answer by the denominator itself. Of the last example, the hypotenuse is we have 9 square root of 2 and the adjacent side is equal to 9. So we are looking for the opposite side. Following the Pythagorean theorem, we have b is equal to the square root of c squared minus a squared. So we have here 9 square root of 2 squared minus 9 squared. 9 square root of 2 squared is equal to 81 times 2, and 9 squared is equal to 81. 81 times 2 is equal to 162, so we will be having 162 minus 81. So we have here the square root of 81, which is equal to 9. Therefore, the opposite side is equal to 9. So sine theta is equal to opposite over hypotenuse. Considering the given, the opposite side is equal to 9 and the hypotenuse is equal to 9 square root of 2. So we have sine theta is equal to 9 over 9 square root of 2. So we can cancel 9 in the numerator and 9 in the denominator. So we will be having 1 over square root of 2. And since the denominator still has the square root symbol, we are going to rationalize our answer by multiplying it by square root of 2 over square root of 2. So we have here 1 times square root of 2 is equal to square root of 2 over square root of 2 times square root of 2 is equal to 4. So we have here the square root of 4, which is equal to 2. Therefore, sine theta is equal to square root of 2 over 2. Then, let's solve for the cosine theta. Considering the given, since we have the same sign, which is 9, cosine theta is equal to adjacent over hypotenuse, which is also equal to 9 over 9 square root of 2. Following the same process, the cosine theta is also equal to square root of 2 over 2. then tangent theta is equal to opposite over adjacent. Considering the given, we have here the opposite side which is equal to 9 and the adjacent side which is also equal to 9. So we will be having tangent theta is equal to 9 over 9 which is equal to 1. Therefore, tangent theta is equal to 1. Okay, that ends our video tutorial for this day, which is all about trigonometric ratios. But before I end this video, let's have first a sort of review or the recap of our lesson. The lesson is all about sine, cosine, and tangent. Reminder number 1. In order to memorize the formula easily, all you have to do is retain on your mind so, ka, towa. So stands for sine, which is equal to opposite over hypotenuse, ka for cosine, which is equal to adjacent over hypotenuse, and towa for tangent, which is equal to opposite over adjacent. Important reminder number 2. If the fraction can still be reduced in its lowest term, don't forget to reduce them if it is necessary. An important reminder number 3 is the process of rationalizing. If the denominator still has the square root symbol, don't forget to rationalize the fraction by multiplying them by the denominator. So, that's it. That ends our video tutorial. Again, this is Mr. Mark Blanquisco saying goodbye until our next video tutorial about trigonometric ratios. I hope you learned from me. Bye!